You know that feeling, right? That one song comes on and suddenly you've got chills. Or a beat drops and you just have to move. It feels like pure magic. But what if I told you it's not magic at all? Today, we're diving into the incredible physics of why music sounds so good. Seriously, think about that one moment in a song. Maybe it's a powerful chord change or a note that a singer just nails. It hits you like a ton of bricks. It feels like it's coming from somewhere beyond science, right? Just pure emotion. And it's not just the emotional stuff, it's that physical pull too. You know, when a great bass line kicks in and you find yourself nodding your head without even thinking about it, it feels totally instinctive.
Well, here's the secret. That feeling, it isn't some unexplainable mystery. It is, quite literally, physics. The sounds hitting your ears are following a very precise set of rules, and it turns out our brains are just amazingly good at figuring them out.
Okay, so to really get this, we have to start at square one. Let's go uncover our first clue by breaking music down to its most basic ingredient, the sound wave.
Every single sound you hear, my voice, a car horn, a guitar, it's all the same thing at its core, a vibration. Something moves back and forth, it pushes the air, and that creates a wave that travels right into your ear. That's it. That's the raw material for everything we call music. So, how do we get different notes out of those simple waves? It's all about frequency, basically how fast the vibration is happening. When those waves are packed really tight, that's a high frequency, and our brain hears a high pitch, like a violin. And when the waves are all stretched out and slow, that's a low frequency, and we hear a low pitch, like a bass. It's a direct one-to-one relationship.
All right, so a single note is just one frequency. But music really comes alive when you put different notes together. And that brings us to the secret of harmony.
So why do certain notes played together sound so right? Well, that's called consonance. It happens when the frequencies of the notes have a really simple mathematical relationship. Their waves just line up perfectly in a clean, repeating pattern. Think of it like two gears meshing together flawlessly. It's smooth, it works, and our brain just loves it.
And then you've got the opposite, dissonance. This is what you get when the math is messy. The frequency ratios are complex, and the sound waves just clash and fight with each other. To use that gear analogy again, this is what it sounds like when the teeth are grinding. It creates this feeling of tension, like something needs to be fixed.
Now look at this. This is where it all clicks. A simple ratio, like 2 to 3, creates a wave pattern our brain can easily predict. It feels resolved and pleasing. But a messy ratio, like 16 to 17, that creates a jumbled, chaotic pattern that our brain reads as tense and unstable. The emotion you feel is a direct result of how simple the math is. How cool is that?
But hey, harmony is only one part of the story. Music doesn't just sit still, it moves through time. And that leads us to the final piece of this puzzle, the absolutely irresistible power of rhythm.
You know, rhythm is really just organized time. It's the pattern of sounds and silences that gives music its backbone. And our brains are the most amazing pattern detection machines on the planet. Rhythm gives our brain a predictable roadmap to follow, and that is just deeply satisfying.
So how do you build one of those infectious beats? Well, it's pretty simple. You start with a steady pulse, that's your basic foot tap. Then you add accents by making some of those beats a little stronger than others. And finally, you repeat that structure of accents, and bam! You've got a pattern, a recognizable rhythm that our brain can lock onto and predict, and that's what makes us want to dance. Okay, we've looked at the physics of pitch, the beautiful math of harmony, and the predictable patterns of rhythm. So now, let's connect all that science back to the only thing that really matters, how it makes us feel.
Okay, so here's the big secret. Music is just patterns. The clean ratios in harmony, that's a pattern. The repeating beats in rhythm, that's a pattern. And our brains are wired to find and predict patterns. It's a survival skill. So when we listen to music and our brain successfully figures out the pattern, it gives itself a little reward, a little hit of dopamine. That pleasure, that joy, that emotion you feel, that is the reward.
So, the next time you get those goosebumps from a perfect harmony or you feel that uncontrollable urge to move to a beat, just remember what's happening. That's literally your brain throwing itself a party for solving an elegant puzzle made of pure physics. It's a celebration of its own cleverness.
So, we've figured out that the rules of music are built on the universal laws of physics. The math is the same for everyone. But that leaves one big question, doesn't it? If it's all just physics, why does one song make you cry while another makes your best friend want to dance? Why does it feel so deeply, incredibly personal? And maybe that's where the real magic begins.